Alright, so on this one I think we can try to figure out for which x's does it converge. Then we can do a little ratio test. So I'm going to go with x to the n+1, but instead of writing x+1 I'll just write x times x all over the square root of n+1 times ln of 3n plus 3, which will give you 10 all over n+1. Okay, that's plugging n+1 everywhere you see n. That has to be divided by or times the opposite or the nth term, which would be that x to the n. And of course on the bottom we'd have ln of 3n plus 7 all over n. Now this is kind of a mess, so but actually I can clean it up just a little bit. I can cancel this, cancels with that, and that's about it. Let me see if I can clean it up a little bit. I have x times square root of n all over the square root of n+1 times ln of 3n plus 10 all over n+1 all over ln 3n plus 7 all over n, right? So and of course I'm taking the limit as n runs towards infinity of this whole thing. Now when you have the product of three items like this, if each one exists and is finite, you can go ahead and take the limit of each one separately, and then the limit of the product will be the product of the limits. Okay, so long as each one exists and is finite, you're good to go. So the limit of x is just x because it has no ends as n goes towards infinity. I could work on this limit separately. To do this one, I'm going to do a little algebra stuff here. I'll multiply top and bottom by 1 over the square root of n. Top and bottom by 1 over the square root of n. That would turn this one into 1 over the square root of 1 plus 1 over n. As you distribute that in there, this would go to, of course, clearly that goes to 1. This goes to x, that goes to 1. What about this one? Well, you'd have infinity over infinity. You can use L'Hopital. This goes to 3 because you have 3n over n. Or maybe you can do it this way, little rewrite. Maybe it's cleaner. ln of 3 plus 10 over n all over 1 plus 1 over n all over ln of 3 plus 7 over n all over 1. Alright, then I try the plug-in method. Clearly this goes to 0, that goes to 0, that goes to 0, so this goes to ln of 3 divided by ln of 3, which is equal to 1. So when it's all said and done, this limit is x times 1 times 1, which will give you a grand total of x. Now this whole thing, we know that will converge. Whenever you do the ratio limit, will converge. If x is less than 1, it will diverge. If x is greater than 1, and no call if x is equal to 1. This is my limit x. So then this is done, that's done. We just have to check the endpoints. So we have to check separately. We have to check the case, check when x is equal to -1, and we have to check separately the case when x equals +1. In those cases, the ratio test would be inconclusive. So we take your x and you plug it over here, and that would give us the summation of -1 to the n all over the square root of n times ln of 3n plus 7 over n. This piece, you don't have to worry about it too much. The limit of that is 3 ln of 3. So that's just a constant. This piece, on the other hand, has an alternating sign. This piece is alternating, and it's decreasing and going to 0. Together, this whole sum will be decreasing and going to 0, eventually, if not always. And you have an alternating series, so therefore by alternating series test, this one converges. At 1, you have summation of 1 to the n all over the square root of n times ln of 3n plus 7 all over n. You can sniff this out and see it behaves a lot like 1 over the square root of n, because that's just 1 and this is just some constant. So I bet if you take the ratio of that, you get some constant, and by limit comparison test, it behaves like this one, and this one diverges clearly because it's a p-series and the exponent is a half, less than 1. or by the integral test, or by Cauchy's condensation test. By a bunch of different reasons, this one diverges. So no go on this one, and we have our interval is between 1 and -1, and we are including the -1. Yippee-ki-yay. So yeah, that was fun, huh? Alright, peace. Next time.